Okay, sorry about that. So can you try to give us the amplitude in meters? So you know you're converging from like from centimeters to meters, millimeters to meters, to kilometers and all that stuff, right?
Is it 0,4 meters?
Yeah, that's correct. So it's gonna be 0.4 meters because you're just gonna take your 40 and divide it by 100. So that's how you convert from centimeters to meters. So they say label the points marked D and E. So okay, can you label them? Because remember, on a wave, you have your amplitude, you have your, you know what? Can you just try to label them so I don't tell you too much?
I'm not sure, but I think D is distance and E is period.
Okay. So what I can tell you is that the period is gonna be stated somewhere. The period is actually just like this line going here. So if you look at the previous notes from our very first lesson, this is the draw and this is the crest of the wave. I don't know if you still have those notes from like our very first from the first lesson we had, but I told you that the highest point on the wave
Uh,
is the crest and
yeah,
the
I
lowest
just
point is the draw. You remember that?
yes, I just saw now that I was wrong.
Okay, but you know, I can say waves are complicated because they have all these things to them, and then you have to deal with the horizontal and vertical at the same time. But yeah, so I don't know, maybe just try to look through your notes and maybe you you can find a better way to understand it. Uh, So they say write down 2 points in the graph that are in phase. So if you can remember, I said points that are in phase form a full wave, right? They just form one full wave and that's it. So can you, from the graph, can you just tell me like 2 points? You can just say A and B, B and C, stuff like that. And then tell me whether those 2 points form a full wave, just from the diagram.
Excuse me, you breaking
Sorry?
you're breaking up like the
Okay.
internet.
So, okay. So I said 2 points are in phase when they form a full wave, right? Um, can you just say like yes at the end to confirm whether I'm breaking or not? Because I'm not sure. So when those 2 points form a full wave, that's when we say they're in phase. So from this diagram,
Um,
can you tell me the points that are in phase?
Is it B and C?
So you're gonna look at B and C. So if you look at B and C, does it look like it's a full wave? Just from your perspective, like just from what I showed you, does it look like it's a full wave? Because like it's not, I don't think it's even, yeah, it's half of a wave because it's not. This is your equilibrium. Let me just draw it like this because this is your equilibrium point, and then this is above the equilibrium. So B and C don't form a full wave. So I'm gonna show you this method. What I usually do is that I just draw a line here, a line here, and a line here. So this is one full wave, and this is possibly maybe 1/4 of a wave. And this is also gonna be a quarter. So from the looks of it, this is gonna be a quarter added to a quarter. Sorry, this is one full pulse, sorry. So this is gonna be a quarter of a pulse and a quarter of a pulse. And at the end of the day, you're gonna have 1.5 pulses, and the wave is formed by 2 pulses. So that means A and B don't form a full wave. But this part here is half of a wave. I don't know if you understand why I'm saying this is half of a wave. So if you look at it, you're gonna take a quarter, a quarter and a half, and add it to this one. You're gonna get 2 pulses. And then that means from A to C, it's in phase. So do you understand it? Let me just rub all this other stuff out. Yeah. If you look at it from A to C, does it look like a full wave to you?
Yes.
Okay, so that's how you're gonna identify your waves. I'm not sure. Maybe I'll try to. I'm not sure if I can find a video on this, but I'll try to get some extra resources to help you. So now we're gonna go into
The video you sent doesn't want to open.
okay. Is it fine if I send the link to the video? Yeah, because I had to convert it. So I'm not sure, maybe like during the conversion, I'll just send you the link after this. So now we're gonna go to 6.4. They ask you how many waves are present in the diagram above.
2.5.
Sorry?
2.5.
Yeah, exactly. It's just gonna be 2.5 waves. And then they say they want you to calculate the wavelength of the wave. So we were actually on our way to talking about speed during our Thursday lesson. So I'm actually just gonna show it to you right now. Remember, the speed is equal to the wavelength multiplied by the frequency. Do you remember this equation? I'm sorry, do you remember this equation from class?
Yes.
Okay, so this is the equation we're gonna use, but this time we have our speed and we have our frequency. We're supposed to find our wavelength. So what we're gonna do, we're gonna divide both sides by frequency. And then we're gonna end up with our wavelength is equal to speed divided by frequency. And from the statement above, we have our frequency, which is 0.5 hertz, and our speed, which is 0.4. So we're gonna say 0.4 divided by 0.5, which is gonna give me 0.80. And what's the unit for wavelength?
Is it meters?
Exactly, it's meters. So that's gonna be our wavelength, 0.80 meters. And then now we're gonna go to our final question where they want you to determine the distance. So do you remember I gave you an equation to calculate distance and wavelength? Do you remember that one? Where wavelength is equal to the distance divided by the number of waves, and the distance is equal to the wavelength multiplied by the number of waves. Do you remember that one?
Yes.
Okay, so just from using that equation, I'm just gonna say distance is equal to what's this? What's that eraser? Wavelength multiplied by the number of waves. multiplied by 2.5. Yeah, so this is basically
I
all
got
the
it
questions.
right.
Okay, that's very nice. So did you get all of them
I
right?
got it right.
Okay.
Yes.
So from all of these questions, like which part did you find difficult when you were doing them?
I didn't find it hard. I was just confused by I was unsure about 6.3 and 6.2.
Okay. So that means like you do have some information about this. So um basically that's most of what I planned. So I'm gonna try to give you how can I say this? Oh yeah, I forgot to mention. Are you comfortable? Are you gonna be on class on Thursday?
Yes, I yes.
Okay, so I'm gonna set a test for you for Thursday.
Okay.
So I think this is like a good opportunity for you to ask me some questions. Or if you want, we can do another set of questions and maybe see how far we can go from there.
Yes, you can do another set of questions.
Okay. um yeah, so this is the one that's gonna be like a bit a bit more difficult, but don't worry about it. I'll explain it to you. So they say the diagram below represents a water wave that's moving from left to right, and the time between two consecutive crests is 0.5 seconds. And then they give you the distance from B to F. They give you the distance from D from down here to here. And the very first question they ask you is what type of wave is this? So can you just try to tell me what type of wave this is? Um, you can just make a guess. You don't have to be right, but
Um, the consecutive wave.
um, so we're only gonna be dealing with two types of waves. So it's the transverse wave and the longitudinal wave. So when you look at a wave like this, is it a transverse wave or a longitudinal wave?
Longitudinal.
So I'm gonna show you this. a transverse wave is something that's gonna go something like this. And a longitudinal wave, most of the time, it's gonna be so you see. So these are transverse waves and pulses. These are not gonna be your longitudinal waves. Do you understand that? Okay, so now we know what type of wave this is. We're gonna move on to the next question. They say write down the amplitude of the wave. So this is a question that's actually gonna be that's tricky in this situation, but I'm gonna give you a chance to attempt it. Can you try?
You were breaking up. What do you?
Sorry, can you try to give me the amplitude of the wave?
Um, is it 3 meters?
Mm, no, sorry. Um, so if you can look at this, the 3 meters is from up here to down here. You can see. So the amplitude is from here to here. So that means when coming to the amplitude, you're gonna have to divide the 3 by 2. So you're gonna be like 3 divide that by 2, and you're gonna get 1.5 meters. Do you understand why? I'm sorry, do you understand why I'm dividing this? Oh,
Yes.
okay. So can you define wavelength for me?
Is it the distance of one complete wave?
Yeah, that's correct. So, and then they say determine the wavelength of the wave. So, okay, let me wait for my internet connection. So they want us to determine the wavelength of the wave. Um, so you're gonna have to look at point B to point F and calculate how many waves are in there. And then you know how to do the rest. Can you get me that answer within like, let's say, let me give you 3 minutes to get that answer. Is that fine?
Excuse me, did you ask me a question?
Yeah, I said, can you answer 6.3 in like 3 minutes?
Didn't you, I didn't already answer the wavelength. I
Um,
said it's the distance of one complete wave.
oh, sorry, 6.4. I'm sorry.
Uh, it, uh, um,
I just need some calculations. So that's why I'm giving you time.
Excuse me, is the distance 3 meters?
Um, the distance is 6 meters. It's this one.
Excuse me?
It's this distance,
Oh, okay, I
the
did
six
write
meters.
that. Is the answer is the answer 2,4 meters?
It's 6 divided by 1.5. I got 4 meters.
Isn't it? Isn't the waves 2,5?
No, because you have to look at the distance. The distance is from here to here. So this part and this part are not covered within that distance. So do you understand it?
Yeah.
Yeah, so this is one wave and half a wave. So you're gonna end up with 6 meters being divided by 1.5, and your wavelength is gonna be 4 meters. So we're gonna move on to the next question where they say name 2 points on the wave that are in phase. So do you still remember what points in phase means? Can you try to name 2 points that are in phase here?
You're breaking.
Oh, sorry. Can you try to name 2 points that are in phase? And you know, points that are in phase, that means they form one full wave. Sorry.
Is it A and E?
A and E. Yes, that's correct.
Okay.
And also, if you wanted, you could also say D and F. But let's move on. So they say the time it takes for 4 crests to move past a certain point in the path of the wave. So what I'm gonna tell you is that the time between 2 consecutive crests is 5 seconds. So now to find the time for 4 crests, you're just gonna take this and multiply it by 2. Because they already gave you the time here, you're just gonna multiply it by 2 here.
You breaking?
Oh, sorry. So they gave you the time for 2 crests. The time between 2 crests. So the time between here and here. And now they want you to determine the time it takes for 4 crests to move past a point in the path of the wave. So that's gonna be like 1 crest here.
Okay.
The second crest here. This is the third one. And let's just form our own artificial 4th one here. So if you look at it, there's 5 seconds between each crest. So that means here there's 0.5 seconds between each crest. So that means when this one passes by a point, 0.5 seconds later, the second one will pass. 0.5 seconds later, the third one will pass. And 0.5 seconds later, the fourth one will pass. Right?
Yes.
Then the time it takes for 4 crests to move past a certain point of the wave. So it's going to be like 0.5 seconds, 0.5 seconds, and another 0.5 seconds. So it's going to be 1, 2, 3. So you're just going to take that and then add this all together. It's going to give you 1.5 seconds. Do you understand it?